Welcome to part 5 of our FT10 series. In this session, we'll break down the technical specifications of the Valleylab FT10 generator. We'll cover power requirements, dimensions, weight, and environmental operating limits. This is important because understanding these specifications is not just about numbers. It tells us how the device will behave in a clinical environment and what constraints biomedical engineers and OR staff must respect to ensure safe, reliable operation. Let's dive in and explore how the FT10 is engineered to balance compact design with robust electrical performance. Technical specifications are the blueprint of any medical device. For the FT10, these details make the difference between safe, consistent performance and potential hazards. Specifications help us confirm compatibility with the hospital's electrical systems, define what environmental limits we must work within, and set expectations for weight and size when planning installation. Specs also guide preventative maintenance and troubleshooting. In short, they are not just reference values, they are the safety guardrails that engineers and clinicians rely on. The FT10 generator is built with reliability and safety in mind. Its output is isolated and floating relative to ground, which helps reduce electrical risks. Cooling is achieved with a combination of natural convection and active fans to prevent overheating during long surgical cases. The front interface is dominated by a 7-inch touchscreen, which provides a modern and intuitive control surface. Connector options support a wide range of energy modalities, including standard monopolar, advanced monopolar, bipolar, and ligature technology, making the FT10 versatile for multiple surgical specialties. From a practical standpoint, the FT10 is relatively compact of the functionality it delivers. It measures just 17.8 centimeters in height, 36.8 centimeters in width, and 46.2 centimeters in length. At just over 10 kilograms or about 22 pounds, it's portable enough to be moved between operating rooms if needed, yet sturdy enough to stay stable during use. Understanding these values helps us plan space allocation in surgical trolleys, transport carts, or storage shelves. It also guides safe handling by staff to avoid lifting injuries or drops. The FT10 is designed to be flexible when it comes to hospital infrastructure. It can operate on either 100 to 127 volts or 220 to 240 volts AC, making it suitable for global use. The line regulation range is quite broad, tolerating fluctuations between 90 and 140 volts on the lower range or 198 to 264 volts on the higher range. Its maximum power consumption is 950 volt amperes, which is significant, but expected for a high performance electrosurgical generator. These figures remind us of the importance of proper circuit allocation and avoiding overloads in the OR environment. Looking at current draw, the FT10 consumes up to 9.5 amps at lower voltages and about 4.8 amps at higher voltages. This is well within the limits of hospital-grade outlets, but still requires awareness to avoid tripping breakers. Another important figure is heat dissipation, up to 180 watts. This tells us that the unit will give off a noticeable amount of heat during use, reinforcing the need for good airflow around the machine and avoiding enclosed or poorly ventilated storage. For safety, the FT10 is equipped with dual 5 by 20 millimeter fuses, rated at 10 amps and 6.3 amps at 250 volts. Fast blow type. These fuses act as a critical protection against electrical overloads. The unit also connects via a hospital-grade 3-prong plug, which ensures grounding and minimizes shock risk. Together, these features ensures that the FT10 integrates seamlessly with the hospital's electrical safety infrastructure, reducing risk for both patient and operators. Environmental parameters define where and how the FT10 can safely operate. It runs best between 10 and 40 degrees Celsius, or 50 to 104 Fahrenheit. For transport and storage, it can tolerate 10 to 60 degrees Celsius. Humidity should remain between 15 to 85%, non-condensing, which is consistent with most hospital environments. Atmospheric range is between 700 and 1060 millibars, allowing the generator to function effectively even at higher altitudes. These parameters are critical for shipping, storage, and global deployment. Respecting the FT10's environmental and power limits ensures safe and reliable performance. If the device is operated outside of these boundaries, say in excessive heat or under unstable voltage, risks increase dramatically. Overheating, component failure, and even patient safety risks could arise. Staying within limits also helps extend the device's lifespan and keeps in compliance with international standards like IEC 60601. For biomedical engineers, this is part of the everyday responsibility of ensuring both technical and clinical safety. To wrap up, the Valleylab FT10 generator combines compact design with powerful, flexible performance. Its specifications provide a roadmap for safe installation, operation, and maintenance. From voltage and current requirements to heat dissipation and environmental tolerances, each figure helps ensure reliability and patient safety. For biomedical engineers and OR teams, keeping these numbers in mind is more than a checklist, it's the foundation of trustworthy surgical technology. In the next sessions, we'll continue to explore features and deeper functions of the FT10 system.